Hello and welcome to another episode of our series TimeXtender Tuesdays. My name is Frank, I'm a solution specialist here at TimeXtender, and today I want to talk to you about how to survive time. Well, obviously not time travel, but we will talk about time intelligence. And while most of you probably already have heard the term, others may think, time intelligence. This sounds like it has something to do with the curvature of space-time. And while we all know, yes, in space, time is all fluid and relative, we also know here on Earth, time, most of the time, is a pretty serious matter, especially in analytics projects. And that is why today we want to have a look at 6 examples of time intelligence and how you can implement them in TimeXtender. So let's have a look at our examples. The first example is a very popular one you have probably already worked with or at least heard of, and one that is very common in most analytics projects that I have worked on. It is called year to date. And so instead of looking at values of the individual months, for example, what you would want to know in this case is how has my business been doing since the beginning of the year. Year to date basically is the running total from January the 1st of whichever year you are looking at up to a particular end date. Typically within a chart on your dashboard, it would look something like this. You have, for example, your individual months, but also you include the running total, the year to date calculation, and that is ramping up over time. A second, also very popular example is the so-called SPLY or same period last year calculation. So for example, you would select one metric for the current year, and to have a reference frame, you would also want to know how did the same metric behave in the previous year, just to have a point of reference, right? Something to compare it to. Our third example takes this idea of comparing the previous year to the current year one step further. Instead of comparing the absolute numbers for each individual month and displaying them side by side within, for example, one visualization, we calculate the actual difference between the current year's metric and the previous year's metric for the same time frame. So you would display the difference, the change between last year as compared to this year. And this would give us what we call year over year, or the YOY. And typically you could also display it in a chart like this. So for example, a green bar pointing up means a positive development in terms of change, and red would mean a negative change or a decrease of sales or whatever. And you could display it this way. Taking the comparison of this year versus previous year even one step further, we could not only look at absolute differences between current year and previous year, but you could also look at year over year as a percentage of the total. This is like a combination between SPLY and year over year in one number, because it tells us about a percentage-wise change from last year to today's year. This is something, for example, important if you have a big variety in sizes of product categories, for example, or countries. If you have a large variation between those, looking at the percentages makes it much more visible than looking at absolute numbers. Speaking of big variations, this brings us to our fifth example, rolling 12 months. This is like a rolling average to smooth out big volatility in your numbers. So for example, if you have a really wild curve with big ups and downs of sales or of temperature or whatever, what you would want to do to actually see the trend is to build an average that is looking at a couple of numbers ahead and or a couple of numbers back from the actual reference time frame. And what that will do is it will smoothen out the curve and enable you to actually look at the trend, see a trend beyond the big volatility of your actual individual numbers. And so in a chart, this would look something like this. So for example, you have your actual numbers going up and down in big swings, a lot of volatility going on here, but then also you have this smooth line going through the actual numbers, showing the overall trend of where the numbers are going. And then, last but not least, we have the running total, or RT, as our sixth example. This is actually a variation of the year to date. So we could say this is the general idea of the year to date, but it's actually much more complex to implement running total, a general running total, than just the year to date, which is one specific case of running total. And we will see what kind of a difference in complexity this may be. So we have talked about 6 very common examples of time intelligence, and in all of the projects that I have worked on, all of them, or at least most of them, have been very relevant to be included in the actual analysis. So from the top of my mind, I can think of one example right away where even 3 of those time intelligence ideas went into even one visualization, to display one particular use case. Right at the beginning of the COVID situation and right before the first lockdown was happening. And so there was a lot of tension about reducing production and what will happen to demand, etc. So this was the overall question. And the idea was, let's have a chart that will display how we did last year. And then let's plot against this the current year, so that we would be able to see which actual impact the whole situation in the current year would make. Just to build this one particular visualization, we would combine the year-to-date calculation, the same period last year calculation, and to display the actual impact to calculate the differences, we would also use the year-over-year and the year-over-year percentage. Within one chart, there was 3 or 4 time intelligence concepts involved just to make one use case, one business case explanation for one particular situation. So you can see these are not just theoretical concepts or anything, they are very real, very important to all of business intelligence and analytics and dashboarding and all of that. So we can say the overall challenge with time intelligence is to compare and aggregate data, metrics over certain periods of time, and the way those time periods are calculated should be defined in one predefined place, right? Just one time, so everybody agrees and uses the same way of calculating those time frames and time ranges, so that the actual metrics that result from these calculations are comparable. And now that we've talked about what it's all about and why it is important, let's have a look at how we would implement something like this with TimeXtender using Power BI and a tabular model. So which steps will we see in our demo? So first we will need to create a date dimension table, because we always need a date dimension if we are talking about time intelligence or even BI for that matter. We will create a new semantic model so that you can see it's really possible to do it end to end within a very limited amount of time. Then we will create a custom measure with DAX that we will use as a base measure to connect it to our fact table. With this base measure, we will prototype the actual time intelligence variance of those measures in Power BI. But then as a last step, once we have prototyped and tested the measures, then we will also take them back to TimeXtender and implement them in our actual project to have them available there for version control purposes, for reusability, for documentation and data lineage. So in the end, it is very beneficial to move your measures back from the Power BI prototype to TimeXtender, to the tabular model, but it is much faster to prototype and test them right away in Power BI. This is the TimeXtender project we will be working on. As you can see, we have one modern data warehouse and we have one project perspective called sales that we'll be working on. In the warehouse, we have already included our fact table. And the first step that we need is to create a date dimension table. And date dimensions are a whole topic of its own. They can be very complicated and very complex. It all depends on your specific business requirements. But for, let's say, 90% of cases, TimeXtender has everything on board that you need to create a date dimension within seconds. And all we need to do is to right click on tables, and we add a date table and we give it a name, and let's call this the order date. And I will start it in 2019, January the 1st, and then we have days ahead, and the default is 1095, and that is not 1000 days from 2019, but instead beginning in 2019 and then days ahead, 1000 days starting from today. And that is basically all you need to create a date table with a lot of common date attributes and with all the dates specified in the date range here. Let's just confirm that with OK, and you can see we already have our date table. It is red because it is a metadata change that is not deployed yet. Next, we need a semantic layer, so our cube, our tabular model, and to add that to the project, we just right click here and say add semantic model. For today, we don't need click and tableau, we just need analysis services. And in here, I will just call it the sales model. Now, we also need a relationship between the order date table and the sales transaction table. So I will just open this up in a new window. And here you can see we have the order date. And here in the order date table, we have the date value. So this is the timestamp basically. And I know the fact table also has a timestamp. So I can just drag and drop from the dimension to the facts and create the relationship between those two. And that is it. I can already close the second window. And now you can see I have a relation in the fact table to the order date table based on the join columns. And now first step, to our semantic model, we will add the newly created order date table. And to do that, we just drag and drop over the order date table and release it here on the tables, and then we will just select the fields that we need. In this case, I will need the date value and I will select it to be hidden. So it will not be selectable directly in the tabular model, but it will be available in the background for joins and calculations. And then we also need the month. That will also be hidden. And the same goes for the month key. And then the first one that will actually be visible is the month's name. So I just select it over here. And the same goes for the year. This number again will just be used for sorting, but the year name should be visible. And also I want the year month name. That is good. We can add that, and you can see the grayed out columns will not be visible in the tabular model, but those with the colored icon will be visible. And now we can implement also the proper sorting. So the month's name will be sorted by month. To change that, I just right click on month's name, select edit, and then here I can set the sort by property, and I want to sort it by month. And then you can see the month name will be sorted by month. So now we have prepped our date dimension, and next we also need the fact table. And in order to include that one, I will also drag and drop it here on the tables, and it will also give me a selection. And I will select the quantity, the unit price, and the order date. And I have selected all three columns to be hidden, right? So we will include that table in our model, but all of the columns will be hidden because we don't want to expose the data directly from the table to the user, but instead we will add, let's use this relationship, but instead of exposing the data directly to the user, we will use a measure to expose to the user the underlying data. And this can be over-engineered in certain cases, but it can also be very beneficial in other cases, especially when you need to apply certain calculations to the data always before displaying it. And in order to do that, what we will do is to implement our base measure. I just right click on the sales transaction table, and in here I can say add custom measure, and this will give me this dialog. And in here we will say this is our sales amount. And then for the measure code, I select SSAS tabular. Data type will be a integer, and the data format should be whole number. And then for the script, we can insert or type out our DAX code. And for this particular measure, I want to do a SUMX of our fact table. So iterate over all the rows in the fact table, and for each row, take the quantity and multiply it by the unit price. And you can see now that I dragged and dropped it from the Object Explorer. I have also created 3 so-called parameters, and like everywhere in TimeXtender, these are super important to keep the lineage intact, even through your custom transformations, calculations, and so on. So always make sure to have your parameters intact. And what we can also do is add a little description, and this is now basically already our base measure. Let's confirm that with OK. And now we have it here, the sales amount. And now what we need in our new cube is an endpoint. To add an endpoint, I just right click on the endpoints and add an analysis services tabular endpoint. For the name, let's say sales analysis services. The server is localhost. And the database name is TX sales. That is basically it. We can confirm that here with OK, and we can deploy and execute. So now we are doing our differential deployment. So only the things that I have changed will be deployed. And now also data movement is happening. In this particular case, because I deployed and executed now the whole project, all of the data will be moved and not just the tables that we have changed, but it should still only take a few seconds. And now the deployment and also the execution is done. So now it's time to jump over to Power BI. And here in Power BI, we have already some dashboards that include our base measure, but do not yet include our time intelligence. And we will now include that into the report. On the right hand side, under the fields pane, you can see we have our date dimension, order date, and just with the 3 attributes that we have selected to not be hidden. And for the fact table, for the sales transactions table, you can see there are no columns, but only our base measure sales amount. So the first example we wanted to look at is the year to date or YTD calculation. And we have already used the DAX language to build our base measure, and we will use the same language to build our time intelligence measures as well. So to add a new measure, all we need to do is to right click on the sales transactions and say we want to add a new measure. And so now we have a measure bar up here, and now we can just insert our calculation. And so in this case, we want to have the sales year to date, and that will be calculated to be the total year to date. The total Y2D expects the expression. In this case, this will be our base measure, the sales amount. And we want to do this for all order dates based on the date value column. So this is a very simple one, right? I already knew that this function exists. I knew which parameters it will need, but there's a lot of very good documentation around this topic. And when you start using it, you will quickly get the hang of it. So I will also format this new measure and say it will be a whole number. And I want to use 1000 separators. And now I have a new measure here, and I can just drag and drop it to my visualization. And now what we can see is we have the actual numbers for each individual month, like 4 million, 3.8 million, 4 million. And over here we have the YTD calculation. So the running total from January, 4 million. January is the same. February is already the sum of 4 million and 3.8, together 7.8. Makes sense. March will add another 4 million, 7.8, 11.8. It makes sense. So this is the running total. That's all you need to do to add a YTD calculation to your model. And you cannot only, of course, use it in a table, although it is very useful for development and testing, but of course you can also add it to your chart. And now you can see the light blue is the actual numbers for each individual month, and the dark blue is the running total, how your business builds up over the year. So that looks very promising already. Let's look at the second example, SPLY, or same period last year. I will not type out all the measures manually, but I have prepared them here to just copy and paste. To add the SPLY, I also do a right click here, add a new measure, then I can just paste it in. As you can see, it works somewhat similar. I use a different function called calculate, base it again on my base measure, and then I use the function same period last year, which will do the magic with my date dimension. Let's confirm that. And exactly for that reason, so not to repeat these process steps every time, it is later on useful to persist the measures in your tabular model. So now we have the SPLY, the SPLY measure here ready. Now I can also drag and drop it onto my table for testing. And what you can see is for the first year, it will not give us any values. That makes sense because there is no previous year. But now if I look at January 2020, it will say 1.99 million. And for February, 3.15. And if we look at the actual numbers from January and February 2019, so the previous year, we will see the same numbers, 1.99 million, 3.15. So we get the correct numbers, but just shifted 1 year. And we can also, of course, do the same thing in our chart. I will just add here the SPLY, and then we can see in the light blue we have the actuals, and in the dark blue you have the comparison value from the previous year. Okay, let's continue on to the next examples, and those two I combined here in the dashboard because also out in the real world typically those two go together most of the time. And that is year over year and year over year percentage. So again, let's add the measures, right click on the fact table, new measure, and then let's just paste in our measure code. So let's confirm that one. And let's also include the year over year percentage, paste it in, looks very similar. So to add this to our table, it makes sense to add the SPLY so we can compare it, and then we add the year over year, and we can already see for January we have the 4 million, the 2 million in the previous year, and then the year over year is 2 million, so increase in numbers of 2 million. And in terms of percentage change, this means we have a 100% increase over the previous year. So this makes a lot of sense. It works just as expected. And not only can we include this in a table again, but we can also include it in some charts. This is typically what you would display those year over year numbers like, at least in the so-called IBCS, the International Business Communication Standard. This is what it would look like. And in this way you would display percentage-wise changes. Let's have a look at the rolling 12 months. So here we can see the sales amount has quite some volatility in it. It fluctuates quite a bit up and down. So to see the actual trend, how is the overall direction of my sales, we will look at the rolling 12 months. And in order to do that, again, we just add a new measure in here and we paste it in, and you can see it, you can do very fancy things. Rolling 12 months, of course, is already much more complicated, but once you have developed this, it doesn't matter because you can just persist it in your model and you can use it over and over again. And also none of your users have to take care of this because it is already part of the model. So this is extremely powerful to have this pre-built and exposed to your users. Just as a side note, depending on your seasonality, if it's not based on 12 periods, because it makes more sense to look at shorter time frames or even longer ones, depending on how your seasonality works, how your volatility works, you can play around with it. You can also not look at rolling 12 months, but also rolling 6 months, rolling 3 months, even rolling 7 days, whichever time frame makes sense, right? You can just adapt this kind of code. So let's confirm that one. And then we can add it to our table. And again, here we can see the actual numbers go from 199 to 3.15 million, right? So quite a big jump, but the rolling average is already smoothing it out, and it's just jumping from 1995 to 2.5 because it will average out such jumps. And again, we can not only add it to the table, but we can also add it to the chart. For example, we add it not as columns, but in this case as a line to just give it more visual distinction. And so you can see the light blue columns are the actual numbers and they keep their volatility and the fluctuation, and the dark blue line is much smoother, giving us an idea of the overall trend. And last but not least, let's have a look at the running total. As I mentioned, this is like the general case of the year to date. The year to date is one special case of the running total, but you can also have a running total that is much more flexible and, for example, does not start at beginning of the year, but beginning of the quarter or beginning of the week or whatever makes sense in your particular case. So also we just right click on the sales transaction fact table, add a new measure, and then paste in the running total. So let's confirm that measure as well. And again, we can add this to our table. And now you will see it looks a lot like the year to date. So it will add up the numbers over the months. But what it will also do is it will not reset at the end of the year, but it will just continue to sum up everything from the beginning of time or from the beginning of the time period that you are looking at up until whichever point it is based in now. So it will also continue to calculate across years or across whichever boundaries the other calculations would observe. This one doesn't, it will just calculate across them. So now let's also add the running total here to our chart again as a line, and you can see across the years it will just keep on growing, keep on growing. You can be really flexible with which time frames you want to look at. So for example, if I select one particular year, it will behave like a year to date. Or if I select even just a subset of months, the running total will give me the running total of just these couple of months. So a lot more flexibility than just with the year-to-date calculation. So that looks very promising. We have tested out and developed all of our 6 measures. So there's many good reasons and benefits of bringing it back to TimeXtender, and we will just do that now. Let's jump back. Okay, so back in TimeXtender, we still only have our base measure here. And in order for you not to look at me copying and pasting again 6 measures, I have prepared the final result, but I will also show you how to do it in the actual result. So let's just switch from one project perspective to another. And surprise, it has another cube in it that looks very similar. It also has an order date table and a sales transaction table. But in the sales transaction table under measures, you will see that it already has 5 of our 6 examples implemented in here. And we will now implement the 6th one, and that is the year-to-date calculation. So to implement that one, let's right click on the measures, add another custom measure, it is again sales year to date, and to keep it in order I will just add a 1, but that's totally up to you how you design, of course, your tabular cubes for your users. I will have it again as a whole number. I will add it as a DAX measure for SSAS tabular, of course. And if you remember, the code is pretty simple: total year to date. And then it will need the base measure, which is sales amount. And it will need from our order date table the date value column. And of course I can just copy and paste it in here. But what I need to make sure to keep the lineage intact is to have the parameters down here. So that is really important, to keep the lineage intact also in the time intelligence measures. So now we have implemented that one. Let's move it up and we can look at the other ones. For example, SPLY will look the same. The formula looks very much the same. The only difference is I have made sure that the parameters down here are intact and are selected from the Object Explorer on the right. And also the more complicated ones, year-over-year percentage, I can do all the stuff I can do in Power BI. I just do it here and make sure that my parameters are still in place. Rolling 12 months, the most complicated one. With the longest DAX code, I can do the exact same thing in here. Paste in the formula, make sure my parameters are set, format the measure, and it is persisted in here. Last one, running total, even also with the comments that we have in the measure, you can also put it in here. You can do whatever you can do in DAX, you can do here in TimeXtender as well. What we did today was of course already very intelligent, but in one of the next episodes we will look at a way of doing it in an even smarter way. We will be looking at calculation groups and how to do time intelligence using calculation groups with Power BI, with tabular models, with TimeXtender, and how it goes together. Many of you have asked us about using calculation groups, and in one of the next episodes of TX Tuesdays, we will look into that together with you. Thanks for your time. I hope you enjoyed and see you in the next one.